Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. But not just another Tuesday live stream, we're continuing a CPU summer. All July, we are highlighting the new modular controllers from Horner Automation, specifically the CPU250. And today's topic is this: using the micro CPU250 with Ethernet IP. Well, Ethernet IP is an industrial network that's ubiquitous in the market, especially in North America, and any machine OEM is probably interested in making sure that their machine is connectable some way over Ethernet IP. And today, we're going to show you how to do that with the CPU250. So without further delay, let's get to it. We're going to start with a very quick review of the CPU250, which we've been highlighting this month. And then we're going to dive into Ethernet IP a little bit. Now, most people are familiar with Ethernet IP, but not everybody. So we're going to get everybody up to speed first. And then we're going to talk about Ethernet IP device classes, which is an area where there's a lack of education in the field for sure. So we're going to take care of that. And then we have two main use cases we're going to go through today. We're going to go through the use case where you're using the CPU250 as your main machine controller, and you want to be able to publish data both directions over Ethernet IP. And then a second use case we're going to talk about, which is kind of interesting, is using the CPU250 as a very advanced Ethernet IP I/O block. So that's the second use case, and there'll be plenty of demonstrations to hammer it all home. Okay, here we go. All right, so the new modular controllers from Horner are being released this summer. The first two being the CPU200 and the CPU250. The CPU250 is the one we're highlighting because of all its great built-in I/O. Now, these are members of the Micro series of products, which before now only consisted of all-in-one controllers, but now includes these new CPUs that don't feature a built-in display, but otherwise have very similar functionality to the rest of the Micro series. Now, these modular controllers are loaded with capabilities, lots of connectivity options with Ethernet and USB-C for programming and micro SD, tons of built-in I/O for the CPU250 at least. You can even add additional I/O through standard OCS I/O blocks that you can add right on the side of the unit. And of course, all the connectivity with all kinds of different protocols are supported. It really is a loaded device. And today, of course, we're focusing on the Ethernet IP capability of the CPUs. All right, now from a built-in I/O standpoint for the CPU250, it's absolutely packed full. And one of the highlights is the flexible I/O, which are 8 specific inputs. They can be either digital or analog, voltage or current, 5, 12, or 24 volts, just highly configurable. The message for the CPU250 I/O is there's plenty of it, and it's highly configurable. And today, as I previously mentioned, one of the applications we're highlighting is using the CPU250 as an Ethernet IP I/O block. Okay, now let's dive into our quick review of Ethernet IP. Let's get everybody on the same page. So what is Ethernet IP? Well, it's certainly one of the most popular industrial Ethernet protocols available today. It's managed by ODVA, which is an organization that was created to manage DeviceNet way back in the day, but has been expanded to include Ethernet IP. Now, one of the reasons Ethernet IP is so popular is because Rockwell, which is one of the leaders, certainly in the United States, in terms of market share for automation, they're definitely a big proponent of Ethernet IP and are promoting it left and right. Okay, now, one of the areas that we need to up the information on is Ethernet IP device classes, because we have customers calling in looking for Ethernet IP support, but they aren't really exactly sure of what they need. So let's talk about the 4 different device classes to really kind of bring that into focus. Okay, the first device class we're going to talk about is I/O scanner. The purpose of the I/O scanner is to basically control the network, okay? And you have to have an I/O scanner on every network. And our example here is a Rockwell PLC. The next device class we'll talk about is an explicit message client, which is a device that can exchange messages, typically tag data, over the network, usually with the I/O scanner. And an example of that device would be a general purpose HMI that's sitting on the network. The next class would be an explicit message server, a device that is just sending messages to the network like a barcode scanner. And then finally, we have the I/O adapter class or I/O device, which is the most common class. So for things like AC drives and temperature controllers and valve banks and those sorts of things, these are devices that provide information to the network and that are looking to be controlled over the network, or at least exchanged data over the network, but they're not controlling the network themselves. Now let's take a look at all the different classes of Ethernet IP devices and how they're supported by Horner. All right, let's start with I/O scanner, the device that controls the network. Now, if you're looking to the CPU250 to control an Ethernet IP network, that's certainly possible, but only if you add a third-party product from a company like Real-Time Automation and interface with that device while that device is controlling the network. And we've done a video on that device, and Real-Time Automation is an amazing company, by the way. I love those guys. So it's entirely possible, but it does require a third-party device. Now, as a note, we are currently working on, in development, adding Ethernet IP scanning capability to the Canvas series. Now, that is being developed, but it's not going to be available until probably relatively early in 2026. So keep an eye on that development. All right, now let's talk about using the CPU250 as an explicit message client. This is a device that exchanges messages, typically tag data, and typically with the I/O scanner, which is usually a Rockwell PLC. Now, this can be a useful function, but it's not all that popular, and here's why. Most Horner customers are OEM machine builders that are using a Horner controller to control their machine, and then they sell their machine into their customer's facility. And the only way this data exchange will work is if you have control or access to the program that's running in the processor of the I/O scanner or the Rockwell PLC. And most of the time, OEM machine builders don't have that access. That's their customer's PLC, for instance. So while this is a connection that is supported by the CPU250, it's not one that gets used all that frequently. So we're not going to spend much time on that one today. The one we are going to talk about is using the CPU250 as an I/O adapter. In other words, when you're using the CPU250 to control your machine, okay, and you want to be able to exchange data over Ethernet IP at your customer's facility so your customer can monitor what's happening on the machine, or maybe your customer can send remote set points or remote control data or something like that. That absolutely is a capability that is very common, very capable, and we're going to cover in quite a bit of detail today. All right, so what is the detailed workflow for what I just talked about? And that is when you're using the CPU250 to control your machine and you want to exchange data, or you want your customer to be able to exchange data from their Ethernet IP infrastructure to and from your machine. Well, here's what you need to do. First of all, you're going to program your application into the CPU250 like you normally would to control your machine. Next, after that's done, you're going to get out your pencil and you're going to design a map of data that you want to share to Ethernet IP. Maybe temperatures and pressures and other status information you want to broadcast to Ethernet IP, and maybe there's some remote set points or remote control bits or something like that you want to be able to receive in over Ethernet IP, or you want your customers to be able to send you over Ethernet IP. So that's what you're going to do there. You're designing the map of data that you want to share both directions. Then in Cscape, you're going to configure your CPU for Ethernet IP support. All right, and then in logic there, you're going to have a little bit of logic that moves those variables that you want to make available over Ethernet IP, that moves them into the right places so they can be broadcast and received with Ethernet IP. And then you're going to publish what your data map looks like. And then after you ship your machine and it's been installed, your customer will be able to use your documentation and exchange data over Ethernet IP with your machine. Okay, so that's the detailed workflow for that first use case. Now, the second use case I talked about in the open was using the CPU250 as an Ethernet IP I/O block, which is kind of an interesting concept. So the workflow is very similar, but slightly different in this case. So first of all, when you're just using it as an I/O block, the first step is to get Cscape out and to configure the CPU250 I/O to meet your application. Because remember, it's highly configurable I/O. You've got those 8 flexible I/O points, you've got configurable ranges with your analog outputs, you've got all kinds of configuration. So just configure it for your specific application using Cscape. Then, again from Cscape, add Ethernet IP support to it with a little bit of configuration there. Still in Cscape, you're going to do a little bit of ladder logic to move the I, AI, Q, and AQ data that's been allocated for the built-in I/O over to the right places so they can be seen over Ethernet IP. And then you're going to be done with Cscape. Then you're going to fire up your Rockwell software and add the CPU250 as an I/O block onto your system. You're going to set it up and you're going to test it. Now, in this scenario, remember what we're doing is we are sending our input data from the CPU250 out over Ethernet IP, and the data we receive in from Ethernet IP, we're going to map over to %Q and %AQ data. So we've got a total of 19 words that we're producing, that's our I's and AI's, and 26 words we're consuming, that's our Q's and AQ's, and specifically all that data is what's been allocated to the built-in I/O of our CPU250. All right, let's dive into the demonstration. All right, let's take a look at what's happening on the bench. So here's my CPU250. All right, it's wired up to my handy dandy I/O simulator. Now this happens to be a first generation model. I managed to blow the fuse on my latest generation model by wiring it up backwards yesterday, but this guy will do the trick for exercising the I/O, the digital inputs and outputs, analog, etc. All right. And then over here we have an old battle axe, Rockwell, compact Logix, where we've got a flashing light because the I/O isn't working quite right at this stage. But for my purposes, which is testing out Ethernet IP and demonstrating that for you, this old battle axe will work just fine. So this is a Ethernet IP I/O scanner is how it's acting. And then our CPU250 is acting as an Ethernet IP I/O adapter. Now in the use case that I'm demonstrating, I'm going to turn the CPU250 into an Ethernet IP I/O block. Now this is probably not your use case. You're probably going to want to use the CPU250 as a machine controller, and you want to have some of your machine data available over Ethernet IP. Well, despite the fact that your use case may be different, this demonstration will give you all you need to know so you can successfully implement Ethernet IP for your application. All right, here we go. All right, so the first step is we need to configure the I/O in the CPU250 for your specific application. All right, so we're going to go to Hardware Configuration, go to the Local I/O tab. Now the CPU250 Built-in I/O is highly configurable, and we need to configure it for your application. All right, so on the input side, you might have high-speed counting that needs to be configured. I've configured some here. Okay, so you would configure that under digital inputs. On the digital output side, you may need to use a couple of the high-speed outputs, maybe as a stepper, maybe for a PWM signal, maybe as an output that fires based on an encoder position, so those would be configured there. On the flexible input side, of course, this is where all your analog inputs are configured that you have, all right? You might use them as digital inputs, depends on the application, of course, so you'd need to configure those here. And on the analog output side, you've got 4 milliamp and 4 voltage analog outputs that need to be configured for the signal type as well as the data range. So all that configuration needs to happen. Now, regardless of how you do the configuration for your application, the way I've designed this example application, all the I, Q, AI, and AQ data for all that built-in I/O will be available over Ethernet IP regardless of how you've configured your specific application I/O requirements. Okay, so that was the first step. The second step is to configure Ethernet IP, and we're going to go back to hardware configuration to do that. All right, so we're going to go under LAN 1, config. We're going to make sure our IP address and net mask are configured. We're going to make sure Ethernet IP I/O adapter is selected and highlighted, and then we're going to hit configure selected protocol. All right, this is where we determine what data we're producing to Ethernet IP and what data we're consuming from Ethernet IP. All right, so from the standpoint of the data that we're producing, this is considered Ethernet IP input data because that's the perspective of the Ethernet IP I/O scanner. All right, so the input data from the perspective of the scanner is, in my case, 19 words of %I and %AI data that is allocated to the built-in I/O. Now, where's that data coming from? Well, it's ultimately coming from I and AI, but I have to put it in this array here. So I've got a 19-word array, where the I and AI data elsewhere in the program is going to be stuffed into, and then that data is going to be broadcast over Ethernet IP. Now, coming back the other direction is going to be 26 words of Ethernet IP output data from the perspective of the scanner that's going to go into this array of 26 words. And then elsewhere in the program, I'm going to take this data and stuff it into %Q and %AQ data to get the data going that direction. And then finally, I have 1 word of Ethernet IP status. What does that do for me? Well, the lower byte of this status word, if it's non-zero, tells me there's at least 1 Ethernet IP I/O scanner that is controlling the I/O. So as long as that we have at least 1 I/O connection, I know the I/O is being controlled, and I can, allow the normal operation of the unit. If the I/O is not being controlled, then I'm probably going to want to turn my %Q and %AQ data all to zeros. Okay, all right, so that's the Ethernet IP configuration. That was step 2. All right, step 3 now is to move the data around appropriately. So let's start with the %I and %AI data, okay, that we want to broadcast to Ethernet IP, or to publish to Ethernet IP. Okay, so the first 3 words of the array that's going to be published to Ethernet IP consist of %I1 to %I48. Those 3 words of %I data that are allocated to the built-in I/O. That's the first 3 words in the array. The last 16 words in the array come from %AI1 to %AI16. All right, so this is the data that we're publishing to Ethernet IP. Now, in terms of consuming from Ethernet IP, here's the array of 26 total words that is receiving the data we're consuming from Ethernet IP. The first 2 words, or 32 bits of that data, we are stuffing into %Q1 to %Q32. The last 24 words we're stuffing into %AQ1 to %AQ24. All right, now you'll notice I have an either-or logic going on here. So that's where I determine, or that either-or is going to depend on whether we're being controlled right now by an Ethernet IP scanner. How do we detect that? Well, we look at the lower byte of the Ethernet IP status register. If it is greater than 0, we know we're being controlled, and therefore everything is okay. If everything is okay, we're going to go ahead and stuff the data we receive over Ethernet IP into our %Q and %AQ registers so that we can control the I/O. If we're not being controlled, that data is old, so we're just going to put zeros in all the %Q and %AQs that have been allocated for the built-in I/O. All right, so that is the logic that we've got here as step 3. And the next step is to fire up the Rockwell software. Okay, now that we've configured the CPU250 for Ethernet IP, let's see how quickly we can get it added to the Ethernet IP network. All right, so here I am with my compact Logix, ancient as it is. From Ethernet, I'm going to go ahead and right-click, hit New Module, and this is where I'm going to add the CPU250. Now I need to search under Generic Module. That's what I want right there. Okay, I want to give it a logical name. This will be the basis for all the automatically created tags. I'm going to call it CPU250. It works out much better. The mapping works out much better if you use integer as your basis for your data. I'll type in the IP address for the CPU250 here. The input instance is always 100. The output instance is always 101. I keep hitting the wrong side of the mouse pad here. And the configuration instance is always 3. Now for my specific configuration, I have 19 input words, okay, from the CPU250 to Ethernet IP. I have 26 output words going the other direction and 0 configuration words. Okay, I hit OK. All right, and go from there. All right, so now let's go ahead and go online, because right now we're offline. Go online. Okay, so we've got to connect to the controller. Okay, we need to download the changes we just made. Okay, so we'll hit download here. Done downloading, change the controller mode back to run. Yes, we will. Okay, so let's see where we're at. Okay, so the CPU250 status is now running, and we now have some additional tags that have been added here automatically. All right, so let's take a look at the input tags. Let me expand those here. All right, and look at this. We have live data. All right, that's looking good. All right, so you can see data that's changing here. So let me flip a couple switches on my I/O simulator here so we can see those changing. Remember, the %I digital inputs are mapped to the first word here. Here's my 2 analog inputs. Let's go ahead and get those twiddled a bit. Let me exercise the first one. You can see it's going up quite a bit. All right, up over 20,000. The second one I'll make go lower. We can see it go below. That's all updating nice and quickly. And then the number here represents our encoder. So let's count up, and then let's see if we can count down. Nope, everything's up on this older I/O simulator, so we're counting up. All right. All right, so we've got live data. That all looks good. Now that's on the input side of things. Let's see if we can make things happen. Oops, I keep hitting the wrong side of that mouse pad. My bad. All right, now let's take a look at the output data. Let me expand that here. All right, and let me make something happen here. We have all zeros. Remember, this data is going the other direction. Let me change this to a value of 255. Remember, this is where our first 8 Qs are mapped. I'll hit enter. And now if we switch over to our overhead view, we can see that all of our LEDs are on. So if we do the binary math, a value of 255 will turn on all those LEDs. Now over here on the software, I'm going to change that to a value of 128. And when I do that, all the LEDs but one should go off. I'm going to hit the enter now. You can see that happened immediately. So that's good. All right. So I would say we are completely done. And it took a grand total of less than 5 minutes to add the CPU250 to the network and to test it and to make sure that everything looks good. All right, that does it for our content for today. But if you need more details on Ethernet IP, we have lots of videos that are available on the topic. And this specific video that I'm referencing here has a lot of detail on the protocol itself. So that's available on our YouTube channel. You can also search for it just from Google. You can also search for it using our great video search tool on our website. Okay, we've got 2 training courses left for the year, 1 basic, 1 advanced. Get signed up on our website. We are going to be all over the Midwest and the South in the 3rd quarter. Here's a list of all the places we're going to be. You can not only see Horner folks, but also some of our great channel partners, reps and distributors, and see some of these new products in action. Lots of ways to interact with Horner online, including our website at hornerautomation.com, our YouTube channel, and we're very active on LinkedIn. All right, so next week, we're going to keep moving along with our CPU summer, and we're going to talk about, for those of you folks who have used our RCC products, we're going to talk about how you can migrate from those products over to the CPU250, because everything the RCC products can do can be done and better in the CPU250. So we're going to talk about that next week. Well, we're coming to one of my favorite times of the year, and that is when I get to go on some bicycle trips. So I pre-recorded this particular video because while this is airing, I'm actually going to be bicycling across Iowa with the biggest bike ride in the United States. It's called RAGBRAI. It's a giant acronym, and it is basically a 400-mile carnival as we move our way across Iowa by bicycle. And there can be anywhere from, I believe, 15 to 30,000 people that do this. And we're not talking a bunch of Olympic athletes. We're talking about regular folks like yours truly. So I'm really looking forward to that. And then a week or so after that ends, then I'm going to be going to Northern Michigan for the Shoreline Ride, which is a ride from, I believe, Alpena, Michigan to Traverse City in one of the most beautiful parts of the United States. So I'm really looking forward to that as well. But don't worry, I'm going to be making sure that our content is created and airing on schedule, even while I'm kind of burning up my calories and probably gaining weight from all the food during these vacations. Okay, so until next week, as the CPU summer rolls on, let's get out there and do some good.